All right.
Yeah, we can get started. So for those waiting to see Engine, I'm your fill-in host, Rayees. I'm at RisingWave Labs. I run the product team. I'll try to channel my inner Engine in this conversation and try to keep the topic lively and conversational in nature. So the topic, as the title suggests, like why Apache Iceberg fails and how to fix it. So we have the right guest. Victor has deep experience in Iceberg, all things Iceberg, specifically catalog management. He's the force behind Lakekeeper, for those who are not familiar. Um, so the format is, like I said, it's more like a chat. We're gonna go through high level overview of what does Iceberg mean, like what are the different components, where are the pain points, how to address them. So it's going to be pretty, um, you know, at a high level, overview level, the conversation. But if you have specific questions, you can post the questions in the QA panel in the Zoom chat, and we'll address them as we go through. And obviously, we'll try to save some time at the very end for any more general questions on Rising Wave or Lakekeeper. So let's first welcome Victor. Victor, would you like to introduce yourself?
Absolutely, Royce. Thank you very much. Hello, everyone in the virtual room. And first of all, maybe thank you, RisingWave, for organizing that webinar and talk about quite interesting topic, why adoption or transition to Iceberg fails sometime, and how to fix it. And I'm very glad to deep dive in that topic and not just highlight the technical aspects, but highlight the business aspects, processual aspects as well. But maybe just starting with introducing, my name is Viktor. I'm co-founder of Vakamo, and Vakamo is a team behind the Lakekeeper. And everyone who is right now playing around with Iceberg, the one of the solution is exactly the catalog what we created. On my end itself, I'm like as you can read probably here, ex-Dremio, ex-MongoDB, but before interesting US startup, I do have a heritage from a very well-known German industry, financial industry, the insurance industry. And if you want to talk with me, not just about the Iceberg, but about the data, I can cover from mainframe ZOS, like COBOL copybook is not a fairy tale, it's a program, and going to Oracle, Informatica, SAS, all that Microsoft products up to MongoDB, Kafka, and now ending with Iceberg. That's so far about me.
Got it. Yeah, no, we'll save the history of data management software another time. So yeah, maybe if you could quickly introduce to folks who are not familiar with Lakekeeper,
Yeah.
if you could do a quick overview, that'll be great.
Absolutely. So maybe just a couple of information beforehand. So if you build a lake house, you have mainly three components: a storage, like object storage from Amazon, or from Google, from Azure, from Minayo. It can be everything. Then you have a compute, so it can be like classical Spark, Iceberg. It can be Trino or something like that. And then what is required for Iceberg is a catalog, the way how to manage the metadata information about the Iceberg table. And that is exactly what we built. We call it right now a control plane, because it's not just about the metadata of Iceberg, but it has like additional components around the fine-grained access control, around the data governance, AI governance. But in a nutshell, Lakekeeper has the implementation of REST specification. The interesting part about Lakekeeper, we made a decision to write that in Rust. And it is under Apache 2.0 license, so everyone who is willing to contribute is more than welcome. It's very interesting and a nice project, so I'm happy to get everyone on board on our side.
Cool. Rust, good choice, because that's what RisingWave is also written in. Seems to be becoming like sort of the gold standard for data infra products. Yeah, if you could do a little bit of a deeper dive into the architecture of what Lakekeeper is for, yeah,
Yeah,
probably.
Yeah.
perspective?
Well, first of all, what Lakekeeper is written in Rust, and the result of that is a single binary that you can run everywhere. And our main focus at the beginning was to enable the self-managed customers, and therefore, if you want to run it, you can do it with like let's say Kubernetes. We provide the Helm chart, and the state of our catalog is not stored in catalog itself. We use a Postgres, so it's all outside of the catalog. So catalog itself is stateless. And the good part is that we implemented the access to every object storages like the classical hyperscaler, Amazon S3 or ADLS, but as well to the S3 compatible storages. So if you're on NetApp or on Mina, you're on Pure Storage, you can use that as well. In addition, what we created is quite interesting, is the idea about how to make the metadata, what you have inside of a metadata JSON file, actionable. And just to give you an example, what we can do, if you're gonna do any change on your metadata, so you're creating new snapshot, you're inserting data into your table, Lakekeeper is capable of to push that event to a Kafka topic or NUTS queue, so you can create all that interesting third-party system to fraud detection or risk analytics, or you want to improve some quality on top of your table. And that is possible as well. But it's not for the data, it's for the metadata. And that's kind of like the DNA of Vakamo itself.
Got it. Thank you. So let me do a quick intro for our Rising Waves folks who are not familiar with Rising Wave. Rising Wave is the way we define it is it's like a streaming database. So it's sort of a combination of a stream processor and a relational database put together in one solution, right? The idea being that from interface perspective, everybody loves SQL. Like declarative approach of how to write SQL is great, but the challenge is on the internals of how to process the data, like going from a more batch oriented to incremental model. So that's sort of the innovation we brought in. So for us, from a data model perspective, all data that's coming in, either upstream data, event streams, database, CDC streams, data lakehouses, they're all, from all practical reasons, they're like base tables. So you can join them, you can filter the data, you can build aggregations, all of the things that you do with typical tables, you can do it with Rising Wave on data in motion. Basically, you can, and then once you process, you can store data internally in Rising Wave with Rising Wave tables. So which is a row store and very conducive for low latency serving. Like if you have really real-time dashboards, things that require sub 100 millisecond sort of freshness, then great, that's a good fit. Or if you want to retain an open format like Iceberg, we have that capability as well, so that you can store the tables natively Iceberg, so that you can use engine of your choice to query the data. Now, our Rising Wave provides end-to-end capabilities to manage, do the lifecycle management of those Iceberg tables, right? From the time you create them, the compaction, plug in the right catalogs, including Lakekeeper, to support from internally, so that the overhead of managing the Iceberg tables is not on the user, right? So from that perspective, you have a choice of how you consume the data will dictate whether you want to store it as Rising Wave tables or managed Iceberg tables. And we are Postgres wire compatible. So from a tooling perspective, ecosystem perspective, we are a dominant replacement for any Postgres. Use wherever you use Postgres, you could use Rising Wave and then the fact that it's incremental model, we can guarantee latencies of really like extremely low latencies, and even the freshness of data in terms of data latency. Even for complex pipelines, we can guarantee under a second sort of freshness. So that's a quick intro, and then a little bit of a deeper dive into what our architecture looks like. We are a cloud native architecture system, right? For us, there is a separation of compute and storage. Your primary storage is, even though it says S3, but it is any object store. We are agnostic to, we are available on all three platform, on three major hyperscalers, AWS, GCP, and Azure. And also you can self-deploy Rising Wave. All you need to do is have Kubernetes management, because we are a containerized deployment. Like Lakekeeper, we are built in Rust, and we are Apache licensed, so that it's a completely open source software. You can, all of the core The kernel is built and all in Rust, so you can deploy. And as it shows in the architecture diagram, we have disaggregation for each of the compute services. So if you have streaming jobs, they have dedicated compute. Serving has its own dedicated compute. Compaction its own dedicated compute. So you have a good workload isolation in terms of elastically managing them, scaling them as needed based on workload needs. And depending on user pattern, if someone could be using RisingWave for both serving and streaming, or maybe exclusively for serving, or maybe for exclusively for streaming. So that dictates your deployment pattern. And because of some compute and storage separation, you can scale them independently. You don't have to have, even if you accumulate data worth years worth of data, you could still keep your compute small because of the fact that we only retain our compute is dictated by what your workload needs are, as opposed to the amount of data you have. In terms of the metadata layer, we have made separate metadata services that allow you to have really like multiple, almost like a multi-tenant model where you can run multiple use cases at the same time on a single cluster with single metadata services powering all of those services. Yeah, that's a quick intro. Now let's go into the actual topic at hand. So, Victor, maybe you can start with giving a quick intro to what the different components are, like for someone new to Iceberg, what
Yeah.
constitutes a Iceberg system.
Yeah, and maybe to link that to the topic, as we said, well, why Icebook fails and how to fix it. So I would probably start that we have like multiple components where we can fail. One of them is the technical, another one is a business, and another one is probably the culture. And now we will touch on the technical side because we have a very well-designed technical parts, like what we need is a catalog services. That's the part when you wanna create table. So you will chat with catalog more or less and say, I would love to create a table customer, and those are the fields of that table and data types. And that is what catalog was made for. And if you wanna run your SQL statement select star from customer table, then you will again go to catalog and ask like, okay, where's that table and so on. And maybe just to go through the list and then talk about the challenges here. The day one is how to create the table. It's what the catalog services has been actually invented. But on day two, when everyone was happy, like and you're now trying to read the table, you're getting sad because your select statement doesn't work anymore, and you see like no results. And the reason is because your Iceberg table contains a billion of small Parquet files, and your metadata is just growing, and your manifest files are, I don't know, megabytes of size. And that is something what to solve the problem is like the compaction services. So what you need to do is actually you need to go and read your 1 million small Parquet files of 1 KB size and compact them to a bigger Parquet files, usually like 256 meg, 512. There are different strategies, but that's something what you need to do. And then it's not just about the technological part, it's for financials as well, because you have to know if you write and you read from your object storage, every get, every list costs you something. So you can imagine if you read like one big Parquet file, it's just a single get, or if you're in 1 million small Parquet file, it's a 1 million gets that will be charged by end of the month. That's why we have compaction services. Then we have ingestion services, and then that is a very crucial part on the Iceberg, because what you need to do is you need, well, to lend data from your source. It might be a database, it might be a stream, it might be IT thing. And again, here are different ways. So we see more startups getting here in that space as well. RisingWave is, well, startup scale up is one of the players who helps you actually to lend the data through the ingestion services as well. There are interesting ways to make change data capture. There are interesting ways how to make some event processing on the way to Iceberg. And that's what we have, like a writing computer ingest services. Well, if we created Iceberg table, you will probably want to read and then we have a query engines, and there are a lot of different query engines what you can use. And again, here's a lot of small pitfalls what you need to think about how not to fail. So if you run your, let's say you have a small data, so maybe you will just go and take something like DuckDB or Data Fusion or even Iceberg. But if you have a huge cluster of petabytes, so you probably need some kind of massive parallel processing engine, and they're like a classical Trino, or maybe you want to go and take some like Star or ClickHouse, different engines out there that allows you to make your analytics. And that's only for SQL parts. And then we have all non-SQL query engines based on like Python or Rust. So Data Fusion, probably to mention one. And then observability tools. Well, you need to look after your Iceberg table. You need to look what's going on there. And here is patience, and you need to be very aware about how you ingest data, how is data has been read. Do you need to recluster, repartition your table? So those are the main technical components, and you need to be careful about like how you deploy the catalog services, compaction services, ingestion services. And as you can see, there are a lot of moving parts, and that's one of the challenges on Iceberg, that before Iceberg, you had, let's say, a single, let's call it a Postgres data warehouse in a box, and now someone, as my co-founder Christian says, with a Thor hammer, just hit on that box, and now we have multiple things flying around, and that is one of the challenge. What you need to think about that. But there are good examples, and that's something what you need to think about to follow. That will help you to develop a lake house which is stable from all that angles. Yeah.
Got it. Yeah, that's a good. I mean, I think I like the classification of those five things because I mean, I know there's a longer list, but these are the five things I would say. So I know this is a very, it's an eye chart. There's a lot of stuff here. So since you are the expert on the catalog services,
Yeah.
uh, yeah,
Absolutely. I love that. And let me just summarize that in a interesting way. As my one of my customers told me, like, imagine we in a year 2017 and we call it a pre-rest era. And that pre-rest era, we've got Iceberg, and because catalog was a main thing. So without catalog, it wasn't possible to create the Iceberg table. We got a lot of innovation around the catalog services, and why we started with Hadoop, Hive, Metastore, Glue, DynamoDB, JDBC, Nessie is probably not here on the list. So there are different catalogs that could help you to create Iceberg table. The unfortunate thing about those catalog was they spoke their own language. So which means like RisingWave or Spark, they needed to go and implement that API in order to use that catalog. So the adoption of Iceberg was very slow. And luckily in 2022, we got the REST specification that actually described how clients should communicate with catalog. And now we're moving to the REST era, where we have all the different catalogs, and we'll touch on the catalog implementation in a second. But that actually made very simple the consumption of Iceberg through the REST specification. So maybe that's kind of like a very quick summary of that large
yeah.
slide.
Let me ask you a question there. So REST obviously is where the consensus is. Everybody's going. Polaris is the sort of the Apache Polaris is the project. Um, Now, if someone is running on a local environment, doesn't want to have the overhead of on a separate REST catalog, what would your recommendation be? Like something for a, or is that even for them? Would you recommend going with REST?
Yes, I would definitely tell the person, if you want to use Iceberg, it's super easy actually to run the REST catalog. Take the example of Lakekeeper. It's just a simple Docker compose, and then you have everything. The thing is, what you will avoid here, if looking like in again how not to fail with Iceberg, if you will develop your service with non-REST catalog, you might see the challenges afterwards, and you might develop your platform even locally with not the latest standard what you can actually have. And therefore, my recommendation is just to go and use REST catalog. Or maybe to ask the question, if you locally, is Iceberg a good thing? Maybe you gotta use Postgres. I don't
Yeah.
know.
So one other thing that this is a question that comes from a lot of our customers. Our customers, a lot of them are on AWS, right? So they are using Glue for different services already. That's
Yeah.
become their uh, sort of the brain behind all the services that power them, right? So for them, they would love to go with REST, but it would be like a separate one-off, right? So I see Glue as mentioned. Do you see any downside or anything that you feel like if a customer, now I'm just giving Glue as an example, but say if they're already using five other services that use a common metadata layer, why not that approach for even Iceberg? What would be the downside?
You mean just to go and use Glue
Yeah,
as not a REST Iceberg catalog, because Glue
exactly.
does provide
Yeah.
a REST. Well, like I just had yesterday a call with a customer, and that was exactly the thing. Because the argument on the customer side was, oh, we have still CSV and JSON, and we need somehow to manage that. So it's why we will probably pick on Glue or Hive Metastore. And it's absolutely okay to do something like that. The question is only, uh, what's the use case? If you're a bank and you highly regulated institute, it might be a challenge on a governance side. It might be a challenge on how you will share the data. It might be a challenge on collaboration, which means at the end of the day, the business side will have an impact on, especially for the innovation, um, stop more or less, because you still need to carry all that um, debts with you. Like maybe a good comparison, as I said, like I do have a knowledge with ZOS, the DB2 and mainframe. Those
Hmm.
are very good systems, but if I'm in a petabyte area, it's probably not the best system today. So, and the question is like, should I invest and pay back my debts and
Yeah,
go like the iceberg? So that's the only one question. But that's again, as I said at the beginning, that's the way how you can fail on a business side with iceberg adoption. So it's not nothing about the technical side. So you can just say, okay, technically I'm good, but on the business side, you might be not able to compete anymore because your competitor is on iceberg, and he or she will just outperform your company. So you got to be careful on the business side not to fail.
got it. Fair point. Yeah, I think that's more a business question. So, all right. Let's go a little bit deeper into REST catalogs because seems like that's the consensus and that's where the market is moving. So, what do you
Yeah.
see the downside? Like, just maybe an overview first on what the options in the market are, and then and see what the pros and cons of each.
Yeah, there are plenty different catalogs. So we can differ between the native services like AWS Glue or S3 tables that provide you practically the interface for that. I know like on Google there is a way as well to use the RS catalog, and probably Microsoft's gonna offer as well something like that. But if you look at the more community open source driven catalogs, you will probably find those three, Gravitino as well, probably in that space. So now you have like all the different catalogs, and what you need to think first of all, that those catalog implements the REST specification, but after they implemented different way the governance part. So like, okay, how am I gonna manage it? Is it just a single use case, or do I want to have a multi-tenancy in my catalog? Am I going to be the IDP itself, or I'm saying, no, I have my central Okta Entra, and the catalog needs to follow that. So those are very interesting questions. And not talking about just the security and governance, but talking about the performance as well. Well, I'm a little bit biased here, but we written in Rust, and I would say we can outperform everything who is not in Rust. I'm looking forward. Maybe someone is going to write the catalog in C++ plus plus or something like that. So I'm quite keen to see the performance comparison there. But that is a very important thing as well. So is performance a key factor for your system? Is the frictionless experience, or can I just go and run the single binary more or less and everything is in place? So those are aspects. So now just to summarize, maybe we do have different catalogs. We do have native catalogs provided by hyperscaler. We have the open source catalogs that can be used by everyone. And not to fail, it's super hard because if you're not inside of that catalog topic, it's hard to decide which to use. And my recommendation is you gotta run the test. You gotta run the POC and to understand like, okay, so what is important for me. And then if you run the POC, please just don't take the technical measurements. Think about from a business side, what is important. Do they need like UI? Do they need to be a self-service way of doing the stuff? Yeah.
Got it. I see a question in the chat which may be pertinent to this discussion. Varun is asking, what about Nessie catalog? What is the reason not to choose it? Do you have a reason?
Oh, you can choose the Nessie, but the question is about the Nessie. What's the future on the Nessie side? So how Dremio is going to support that, since Dremio itself uses Polaris, and
Yeah,
that's the only one question. Like, why would you choose a Nessie if you have Polaris? You can use Nessie, and I know like Bauplan uses Nessie as well, and other companies as well. But to be honestly, that's the only one question. Like how good maintained that catalog is going to be.
got it. Now I know you talked about functionally, they all have the same specification. They may cover, you have mentioned about performance and, those are obviously the reasons. But what about in the adoption itself? Once you move to pick a particular catalog, what are some of the pitfalls that one should be aware of?
Well, the first thing, maybe on the security side, and you have that point exactly there. Uh, in our understanding, and when I talk to my customers, that catalog should not be an IDP. Imagine why actually maybe going back. So if pre-Iceberg on the Parquet era, if someone wanted to work with data, so what you need to do is to go to your S3 bucket, create access key, secret key, and give it to the analyst or scientist. And actually, from that time, you don't have any control anymore. So that governance is more or less gone. So because you don't know what is going to happen with that access key, secret key. So to solve that problem, Iceberg specification, REST specification, has a mechanism called vended credentials. That's a way how catalog is going to issue a token that lives, I don't know, like 10 minutes to a client so the client can go and read the file. So you don't need to go to your bucket anymore and create access key, secret key. So we solved that. But now the question is like, okay, so what about the catalog itself? Can catalog create a personal access token that will
Mhm.
live for the next 180 days? And imagine you will actually fire the person from your company, but that part is still alive somewhere.
Mhm.
And that is a huge security hole from our perspective if catalog can create the part or something like that. So in our understanding is the catalog needs to connect to IDP. IDP can issue the token. IDP can create the client ID client secret that can be used in your Trino, in your engines to read the data. That's
If this is
one
such a
thing.
core requirement, why is it not in specification? Like, or is it like a thing that the implementation detail left to the vendors?
Well, like Icebook is quite young product probably, or young specification, young community, and the just to take kind of like in a protection Iceberg community, everyone compares Iceberg maybe with something like Oracle, which is 40 50 years on the market and created all of that standards. So Iceberg takes just a while to get there, and same as here. So I would say like in the next 5 years is going to be probably part of a specification. I see a lot of discussions around the UDFs and policies and get that inside of a specification. So I know like everyone is like, let's get it yesterday,
Yeah.
the whole solution. But the truth is that we need to develop that. And maybe on that point, I would love to highlight the power of open source, and that like I'm usually asking people like who is using open source, and I see like 90% raising the hand, but how much of you contributing to open source? And maybe 20, maybe 30% of people raising the hand. So the thing is, if you miss that type of a specification, go and contribute that. And then it's going to be part of the iceberg. Yeah.
Got it. Got it. All right. I know you covered security. Do you have anything to cover on the maintenance? Anything on the in terms of pitfalls there?
Yeah, so that's quite interesting point, and especially like depends who you talk to. So the question is like, as I described, the problem of iceberg is that you need sometimes go and clean it up. You need to compact, you need to expire snapshots because you don't want to have like a time travel for the last 10 years or something like this. So usually like 30 days is completely okay. And therefore you need actually to go and do that stuff. And the question is like, who is in charge of that? Because again, here the expectation from a customer, like from engineer, from data scientist, even from a business user, is similar what they know from, let's say, Postgres. No one is asking like Postgres, did you do vacuuming? Did you do the whole maintenance stuff? So Postgres is just running and do the stuff. And similar is here. So do we have a catalog that can provide such a service? Or should it be inside of some query engine? From our understanding is that catalog is actually the best positioned here to provide the maintenance services for most cases, not for every cases, because sometimes you need that, let's say like RisingWave, who is going to write the data, needs to take care about the maintenance maybe in the first place. But I think that at the end, not to fail here, the community needs to provide the solution that everyone can just use it. And to be honestly, today that's one of the main thing that probably stop or well makes the adoption very hard for companies
Got
because
it.
it is a very complex topic.
Got it. Got it. I think that's an excellent segue to to sort of the next topic, which is compaction services, right? So in general, I know this is the hidden part. This is the part that's obviously the end user doesn't shouldn't really worry about, but someone has to keep track. This is the life cycle management, like you said, vacuuming, ensuring that the sprawl of all the small files that are created over time are optimized and the size so that on the read side you don't pay the penalty, right? So let's talk about that and see what are your thoughts on the traditional approach of using Spark to be the compaction service versus native Iceberg compaction services. If you could, go into a little bit of detail, that'd be great.
Yeah, so first of all, Spark does the great job, right? And Spark is probably the go-to today to run the compaction services. It is battle proven. It has a lot of different strategies implemented inside, and that's the way how we can solve it today. The only one thing is Spark is not simple, right? So I mean to run the Spark cluster, and then if you listen to some presentation like recently Netflix or LinkedIn who goes beyond exabytes of data, and then you like okay, so how to run such huge massive parallel processing to compact the stuff. Um, but at the end of the day, as you said, it's similar. Like everyone is happy to consume and expects that system just works. It's similar like if you go in your kitchen and you want to get tap water, it should be drinkable, right? And
Yeah, I
and
was
not
thinking
like
of the same. Just as you're speaking, like, what is the analogy? Like, open the tap, water will come. Not sure how the plumbing is done. No one wants.
exactly. Well, there is a huge machinery in the back end, and
Yeah.
everyone just trusts that that machinery works. And that similar is here. So what we need to get is similar machinery. Today, I can tell you from a data engineering standpoint that I have a lot of discussions about the compaction part. And the unfortunate thing is it is complex and it is not easy. It takes a lot of resources to get it done, and it is expensive. I mean, let's be honest. The way of how Spark it does, it's not the cheapest, not the most efficient, and it's why we see more and more startups innovating here around the compaction with Rust-based engines. And I think that in the next 2, 3 years, we're going to solve that like for most use cases, as always. They're going to be like edge use cases that not going to be solved easily. But for most use cases that we're going to get something based on Rust or maybe on C, to get it smooth and cheap. And we will probably build that inside of Catalog as well, so you can just go and click the warehouse and tell, okay, please make the whole compaction for me. Yeah, but again, we need to dig into that,
Yeah.
and that's something what is going to be part of a solution in the future.
Yeah, no, I think you covered some of this, like Spark maintenance, like in terms of pitfalls. Spark is very resource intensive. There's a lot of tuning parameters. There's Java garbage collection. There's a whole host of issues that you expect. If you're a Spark expert, then obviously, it's sort of like there is some prerequisites you need to have. Yeah, and then of course the cost aspect, like how expensive can it be? No, both on the capex side or both on the opex side, right? Like both, you need the right people to manage. So yeah, I think here the shameless plug from my side, right? We built a Rust-based compactor for Iceberg. That's part that sort of powers our Iceberg table maintenance. So it's a built-in Rust compactor. So that addresses some of the, obviously it doesn't address all the issues. So I think some of those issues we can talk about. So do you have any, before we move on from compaction services, anything else, pitfalls that you want to highlight, Victor?
Same as here, guys, as before, contribute to open source to solve that problem. That goes mainly to the technical folks right now. So just use the momentum, because he is the true innovation, I would say. So you can learn a lot.
Got it. Thank you. Okay, let's move to ingestion services, because this is the part that actually deals with a lot of the developers. This is the part where how do you bring in the data, right? That this is what where the value of actually discovering what Iceberg can deliver. So can you give us a high level overview of what the consideration should be, like depending on different modes of how people bring in the data?
Yeah. So first of all, the question is like, is it a database what you want to replicate into Iceberg? So let's say you have the OLTP use case with Postgres, MongoDB, Oracle, MySQL, and then someone is like, okay, so we're not gonna get the analytical workload on OLTP databases, which is a very crucial thing. So don't run your group by queries on your OLTP, because you're going to be very upset that your microservices will suffer. So that's one use case. Then we have a lot of streaming use cases. So you can imagine you have a click stream from your web page, you have your IoT devices, you uh, connecting car probably. me here with German examples, that all that devices needs to stream the data.
Pragmatic,
So
yeah.
you have that streaming and so on. So on the first use case with Postgres, there are a lot of technologies what you can actually do with change data capture. The classical one, so you can go like to a big solutions. I know like the Informatica at Unity, like from Click offers here something. We have some new players around that as well who can help you, like Oleg by DataZip, who provides an interesting solution. And recently, even if you look at Postgres, it offers a direct offload mechanism to Iceberg, that makes that kind of like easy, right? So you probably sometimes don't need to do anything. You will just go to your Postgres and tell, okay, do that. But I know it is very um, a, a hard technical decision, because you need to understand what is the use case. You need to understand on the business side. And here maybe a pitfall, that if I talk to technical folks, they say, "Oh, I need to change data capture, and I will probably need a real time, right?" So that's the best thing, real time. I'm like, okay, what's the real time, and why do we need that? And if we go with a technical person to a business side and asking like, when do we need that data? Well, we refresh that only in the 7 a.m. and that's a good. So and that's a huge thing to consider, how you're gonna do the whole replication of your data. Yeah, so probably
Yeah, I
we'll
think
stop here for a second.
that I think there is three modes in ingestion, like the one-time loading when you have to backfill the data, the periodic loading, for example, if you have that model, and then the continuous, like a clickstream sort of approach. So I guess is there of the three, is there a specific mode that has the challenges, or is there one single solution, I guess, that addresses all three?
Yeah, well, there's as always, you don't have a silver bullet, and there is no singularity. So you will have every possible thing here. But at the end, if you do change data capture, you will end up with a lot of small files, and then you need to think about the compaction services.
I guess they are interrelated. Like you solve problem you need to have a holistic view of what
Yeah.
one will impact other. Um, yeah, I think we covered I think the exactly one some of the semantics, like in terms of guarantees, the CDC solution that you pick should address these issues. Like how does the solution guarantee exactly one's consistency? How does it handle backfilling as opposed to continuous updates? How does it handle schema evolution if changes happen upstream? How do they get carried over to Iceberg, and then small files, obviously, as Victor, you mentioned about having the impact, like if you have too much fragmentation in data, that obviously would require you to be more aggressive on the compaction side. So, okay. Let's switch. I know we're going against the time, so I want to make sure we give uh, all the topics enough time. Query engines, because this is the part obviously that end users are most um, care about, like how to actually query the data and get it out of Iceberg. Um,
Yeah.
yeah.
Maybe my thoughts and my perspective on the query engines. Like before Iceberg, it was a crucial decision what query engine you're going to choose for your workload, because it was very, very important to understand the use case. Is it more on a self-service? Is it more like, oh, I just want to read the data? The let's say the blessing to a customer is that the Iceberg Lakehouse made that decision not very important anymore. So query engines got more or less like a commodity in that case. And through specific ways, like with DBT, for instance, you can abstract the semantic layer and deploy that on a query engine, what you need at the moment. And what we end up in a large customers usually that they have a lot of different query engines. But if you will build that correctly and your data is inside of Iceberg, and your semantic layer can be deployed very easily. And therefore, this topic that was very hot for 2 or 3 years now is getting like rock solid, because every query engine has already kind of a solution how to read data from Iceberg.
Mhm.
And maybe just to give a different perspective to the query engines, because sometimes they feel threatened by Iceberg. It's a blessing for them as well, because I give you kind of a comparison on a construction. In You want to build a house, you don't take a hammer to build the house. You need all the different tools. You need a screw, you need a drill. So you will take a specific tool for your specific task. And same on the query engine side. So for instance, I want to just run an SQL statement. I can go and take like Presto Trino. I want to have a kind of like observability, and I know ClickHouse is good. Then I need something else, like, okay, I don't want to manage Snowflake. And that's like the beauty what we have with Iceberg. And they all just going to connect to Catalog, and Catalog is going to help to provide the governance for them.
Yeah, I think this is I think the greatest strength of Iceberg, that there's a single format that allows you to, based on workload, bring in engine as you see fit. And I see graph, I see so many multimodal. I mean, in the previous pre-Iceberg or pre-open format era, you would have to have a siloed architecture where every
Yeah,
system had their own data format, almost like have to maintain gazillion systems. So that I think is probably the single most important value prop.
absolutely,
Yeah.
absolutely. And as I'm sometimes joking, Iceberg is the last migration, so you don't need to migrate anymore.
Uh, Hope that's true. So let's talk about the pitfalls. I know the engine. One of the key things that you come across is this way the deletes are handled. within Iceberg, right? Some people may not be familiar with the concept of equality delete versus a position delete. Can you talk about what they are at a high level, define, and then what could be reasons that could cause issues?
Yes. So what we have, like, not just only that, so we have copy and write and merge and read and all the different strategies how to write to Iceberg, right? So if we on a batch, so we will just go and then write the parquet file and overwrite the information in a form as we need. If we want a streaming, let's say like Flink, it will actually not rewrite the file. It will just write, oh, I actually deleted that state. So if you want to read it, you need to more or less ingest all that files and as a query engine understand what's the current state. And unfortunately, the query engines in the first place have been built for a batch, and therefore they can actually handle wonderful like the position deletes. But on the Flink side, if we have that type of operation, it will take a lot of computation IO side. So and that's something what needs to be considered, how your data is stored, and again how you're gonna make the maintenance of that part to improve the capabilities of your query engines. Yeah, so
Yeah.
that's probably the main thing.
Got it. Got it. So in a way, I think like you said here, if it's a streaming CDC engine, you typically have very sporadic changes. So you can actually store the value that got changed and you can reference it by a primary key. And then how Iceberg stores is those separate delete files. They are smaller in number, so they're fine. But with batch or upload, there's a whole bunch of changes happening. So it's more like an overread, scan the whole table and reference the file path and number. So that's more conducive for more batch ingestion. Um, let's talk a little bit about, there's the notion of internally managed Iceberg tables, which is basically like S3 or others that are completely managed. What says externally managed tables, which are basically a query engine doesn't have the control over the table maintenance part, right? Like, um, what do you see are the, I know this is getting a little bit deeper into the weeds, but I think that's an important distinction because when a customer has to make a decision about Iceberg, they have to pick a path, right? Do you go with like a vendor managed or do they manage on their own? So what do you see are the main pitfalls there?
I Yeah, so I would love here on that slide actually to give you a little bit non-technical perspective, and everyone who is making that decision, you need to ask your question: is data a competitive advantage for my company? And if that's the case, and you will answer yes, you need to think about like how you want to control your data. And if you will let someone to control your data and not being like, okay, how to maintain, how to compact, what tool I want to actually use for that specific purpose, then you will probably end up in a situation that your competition is going to be faster than you on your data. But that is usually the answer for a very large companies. I know that on SMB, even though if they use data as a competitive advantage, it's super easy for them just to go and use something like Snowflake or Databricks managed tables because it's all well integrated. There is a promise of no ops. It is or usually not fulfilled completely. You still have ops even on Databricks and Snowflake. You need to add additional tools to integrate the whole stuff, the whole stack. But my advice here is the non-technical advice is talk to your business. Ask is that something what they need to compete with someone, and then you will probably go to the self-managed part. If that's less the issue, you can go to the fully managed. The good part is here, the iceberg itself, it lives in a S3 table, in
Mm,
a S3 bucket. And
yeah.
if you want to move it out, you need just to make a registration in the other catalog, and then you're good to go. And probably in a near future, we will have a catalog federations, and that will make the problem even more less problematic, I would say.
Got it. So is that the federation part of actually decoupling so that you could move from one to another? Is that part of V3 spec, or do you know when that is expected?
So here, maybe just to highlight that my co-founder Christian, he was proposing the changes API that has will become part of a REST specification, and it will take now a time just to get it into. The thing is about the REST about the federation is, and maybe that's again a kind of a good advice for someone. You don't need to make a decision. I have only a single catalog, as same as you don't need to make a decision. I have only a single compute engine. Uh, I don't know, probably the same as you don't have a single storage, so you can use like Amazon and Google at the same time. But the federation will allow you to be very self-contained, to have a self-contained teams that can start with, let's say, open catalog on Snowflake, and then you will get someone from a different department who will run a Unity catalog. And then CISO will tell you, okay, let's kind of federate that. So the whole company has access to that data, but they're not kind of like making troubles to you as a team, so you can just work and do your stuff. And that's actually how you will go to federate the whole thing. And I see the slide here how to manage Iceberg, fully managed and self-hosted. Well,
Yeah.
maybe there's a hybrid. I don't know, like a different. But
Y-
like because we almost at the end on our
Yeah.
time and the slides, maybe one thing what I would love to mention here on that slide. You probably noticed we had almost 1 hour, a very deep technical conversation, talking about compaction and iceberg and services and how to make a maintenance. And unfortunately, the business is not following us. And my proposal would be even on that one, on that decision, you have to translate that to your business to make that kind of like understandable for them. And then it is easier to make that decision. You want to go like fully managed or self-hosted, because if you will talk to your business, they don't understand the difference. They
Yeah.
don't understand like why should they go to fully managed or self-hosted. Well, they will probably tell you let's go fully managed. But if you're going to explain them, well, then you will probably not that fast on the innovation part. So the decision will be different. Maybe let's go self-hosted. So yeah, that's
Yeah.
something what I want to bring up to the end. Talk to your business,
Yeah.
and that will help you to shape your culture on that iceberg side. So it's not like a very lonely discussion on the technical data engineering side without business people.
Yeah. No, I get your point about the innovation, the pace of innovation can be different from both because um, what about the cost aspect? Like, does someone like, hey, I don't care, whatever the cheaper option is, what is your general take? Is it better to go with a fully managed because not just for the hardware, like for the
Yeah.
resources, but general overhead of maintaining and all. If you total cost of
One
ownership, yeah,
Yeah, wonderful you brought that point. That's exactly the thing. So what is the cost? Is it just that you will pay to someone who is going to manage that for you? Or is it total cost of ownership on the way how my company works, how I want to develop? What about the risk management in case I have a fully managed done by someone, or a risk management on self-hosted as well? Because if I self-host something, I need people inside of my company who understands the stuff, and that is a part of the total cost of ownership that usually, from a data engineer perspective, well, I don't know. I went to LBS calculator, I typed everything, and now I see exactly my total cost of ownership. I'm like, well, no, that's not the true total
yeah,
cost of ownership. And the next part is ROE. That is absolutely not part of any data engineering talks. Like, okay, so what is the return on investment? You're going to put the money in one of those decisions. So what the return on that is going to be inside of your company, and that's something what needs to be discussed.
yeah,
And then you need business.
yeah. No, I think the return on investment about whether iceberg is the rate, I think that's a larger question. But at the same time, I think having a more uh, discussion about the skill set you have in the team, sort of experience of managing versus taking a vendor solution. I think that's a valid question. I think we did cover some of this. So let's see. We have only a couple of minutes. Are there any closing thoughts? I don't think we have time to take questions, but I want to give. I know Victor, you have a hard stop in a minute or two, so I want to make
Yeah,
sure that is there anything um, for someone starting new? Any resources that you would recommend where to start?
yeah, absolutely. So on that part, again, we'll refer to the open source. So it's way easier just to go somewhere like the Apache Iceberg community, go to Slack, talk to people, try to solve the issue, try just to play some playbook. Like for instance, what we've done on Lakekeeper is the examples with Docker Compose. So you can just go and run the whole environment with Mina, your Lakekeeper, Trino, and all the different tools and play around. So that's for the technical thing. For the cultural thing, definitely talk with someone who is on the business side and understand why they need it, and not just going and then implement some near real time without a business need for that. So you need to ask always the kind of a question. So what if we have that solution? So please keep that in mind that you have always two aspects, technical and business.
Got it. I'll take one last question just because it's there. Who, in terms of communities or companies, setting the standard for solving compaction? Looks like I know it's the iceberg community, yeah, which is a opaque term, but I don't know if there's specific person or department that we there is that it's a it's obvious by nature it's like the whole community, right?
Well, my answer would be the customer. At the end, I hope that was a question from a customer. So you will make that standard because you're going to pick the solution, as the customer picked the solution of Icebrook and told like, okay, that's something what we need to do and what we want to use. Not like specifically Icebrook, but the requirements have been like set in stone, and it was implemented. So the customer is the one who is going to define the standard.
Got it. Okay, let's stop there. And if you have any other questions, you obviously can join us Slack and then post questions there or reach
Absolutely.
out to us. We'll share the slides for this presentation. Thank you, Victor, for making the time. I know it's late in the evening for you. And I want to thank all the attendees who took the time to attend the webinar. Hopefully, it was helpful for you. Thank you all.
Yeah. Thank you guys and reach out on LinkedIn and Slack. Bye bye.
Bye.